And would you look at that, we got ourselves some cool ores in the world, spawning everywhere, Overworld, the Nether, as well as the End. That's pretty cool. Let's see how to do that. And welcome back to the CurseForge Academy channel. In today's video, we're going to be talking about how to create ores that spawn in your world. Now, of course, what we already have, if you've gone through the previous tutorials that we've done, then you may or may not already have the ores added, the auric and the deep slate ore. We will also be adding 2 more ores, 2 additional ores, and then we will be going through the entirety of Worldton. Of course, we have timestamps linked down below because the first thing we actually need to do is update to 26.2. Luckily, this is a very, very small and minor change, at least for us only, where this is going to be for Neo version 26.2.0.12. And then, of course, micro version is 26.2. And then version here is 26.2. That's going to be okay. And we can hit the sync Gradle changes in the top right corner. Or if that doesn't appear, open the Gradle tab and click the Sync All Gradle Projects button. This might take, for me right now, it just took 2 seconds. That was very fast. It can sometimes take up to a minute or so, but generally speaking, that should be fine. Now, the only difference that concerns us for 26.2 to get the update going is to go to both of our tag providers. As you can see, there are a couple of errors right here, and we simply want to replace the get with get key. And that is basically for all of them, we want to simply call the get key method, and that is, basically all that there is to it. This one as well. There we go. And then here, I do recommend, so this one, we are using the add method with multiple different parameters. We're going to change this to basically call the add method for each of them. It's going to look a little bit weird, but you will see that it's not actually as crazy as it might seem at first glance. And there we go. Of course, as always, you also always have the code available to you down below in the GitHub repository, so it's always linked there. So highly recommended to check that out as well. With that one fixed, we can go to the mod items where we basically have to do the same thing. We're basically replacing the get method with the get key method. And that is going to be all that we have to do for our purposes right here. Of course, behind the scenes, there are quite a few number of changes when it comes to, other topics and other things. But for us, this is basically everything. And I'm pretty sure even the rest over here is all fine. So that should be totally good. And in theory, we are now updated to 26.2. When it's done, the next step is going to be to add the other 2 blocks over here. So this would be the Nether and the End ore, because I don't only want to show you how you can spawn blocks in the overworld, right? So in this case, to get the ores generated in the overworld. No. We're going to also have them generate in the Nether and the End for like an amazingly rounded experience over here. What we're going to do is I'm just going to duplicate this particular line over here twice over because the ores are very similar. So we are just going to change the name right here from the auric deep slate ore to the auric nether ore. And every time you duplicate something, always double check that you also change the name right here to the nether ore. We will also then change the type right here to netherrack, as that does make a little bit more sense. Then right here in the second deep slate ore that we've duplicated, we're going to change this to the end ore, and the same thing goes here, end_ore. Double check those definitely, and the sound type for that is actually just stone, because there's no end stone type, like sound type. Very strange, but it is indeed the case. And as per usual, for the blocks, we will need to go through the same process sort of every time. So the first step here is to add a loot table. Now, once again, this is going to be the same loot table as the auric deep slate, which is pretty useful. So we basically just need to replace this with the nether ore. So we can double click this one right here, and the same thing here. So I basically just double click on this. I delete the entry that's already there. I delete the dot that is there. Type in the dot again, and then it basically suggests to me what I need, in this case the nether ore, and then here the same thing, right? I do this again. Here I say end ore, and then here in the drop I also select the end ore. If you want to, you can of course change the number of drops depending on what ore you're mining, but in this case, when it comes to the numbers, as always, you can always change them after the fact. That's a very, very easy thing, of course. And also, when it comes to the numbers, that is really a thing where you need to basically look at your game design, your modded design, and see what you want to do. Of course, we also need 2 times, well, to call it right here in the mineable with pickaxe, because of course, both our nether ore right here, as well as our end ore, are both only mineable with a pickaxe. And in theory, you could also decide to make them only mineable with a certain tier. In this case, we're not going to do that. I'm not going to do that. But of course, that is once again one of those things that you have to think about. Okay, should it make sense that the end ore maybe is only mineable with a diamond tool? I think that might make sense, but then again, you're probably always going to have a diamond tool when you're in the end anyways. Food for thought here. Then in the models, it's the same deal, a trivial cube for both of them. So just once again, I just highlight the line. I'm just on the line, press Ctrl D to duplicate that line. And then I'm going to choose the nether ore right here. And then here, the end ore. There we go. And that's basically all that we're doing right here. And that is going to be that. Let's also add them to the creative mode tab just so that we have them, just in case. It's not strictly necessary, but it is always a good idea to have this, and that's going to be all of those. Then the final step is the assets, and then we are done with the sort of setup over here. Of course, first of all, the translation right here, and then the 2 textures, which are also, of course, going to be available to you down below. That's going to be the auric. This is the auric end ore and the auric nether ore. That is once again, of course, going through how we can add blocks over here. Just a quick sort of refresher as well, but there we have it. So that's going to be that what we need, and now we're going to tackle the world gen. Now, an important requirement for the world gen is data generators. So we do need all of the data gen set up, because for, well, world gen is nothing else than JSON files, and those JSON files are of course going to be generated once again via data gen. So if you do not have data gen, then you will basically need to add this. Highly recommended to check out the very first tutorial in the series over here that can, well, get you done, like set up with data gen. Highly recommended there. And then we're going to make a new package in our Academy mod package, and that's going to be world gen right here. And there we will need 3 Java classes, and I'll explain each one after we create them. The first one here is the mod biome modifiers. Then the second one is going to be the mod configured features, and the third one is going to be the mod placed features class. Those are the 3 different classes. I'm going to order them. First, we have the configured features, then we have the placed features, and then we have the biome modifiers. To sort of quickly summarize what each of them do, the configured features is creating a configured feature. Now, you might say, wow, that's really amazing, as if it was in the name. Okay, the idea is that features are certain things like a tree, for example, right? You can define how a tree looks like, and that is a feature. And then you can configure it, basically saying, hey, this tree should be this tall or this short or have this many leaves, and that's the configured part of the configured feature. So that's basically how a feature looks like. And then a placed feature takes this configured feature, so how it looks like, right? This is how our tree looks like, or this is how many ores are inside of our ore vein, for example, and then places them down inside of the world. And this, of course, has a lot of questions surrounding it, right? So how many of these ore veins are we going to place down? And at what Y level are we going to place them down? That is what the placed feature does. And then the final step is the biome modifier. This is a NeoForge specific way of adding your placed features into the world. So here we define in what biomes are we going to place this. That's the idea. And that's the configured feature, placed feature, and the biome modifiers. Before we jump into making each one individually over here though, we do need to do another thing, and that is to, well, basically unprivate a couple of methods that we will use later in the placed features over here. Those are located in the ore placements class over here, and those are these 3 methods. The reason why they're private is I'm not quite sure. I mean, basically because they're only used in this class, obviously. However, those are very useful for the ore placement to just make it a little bit easier for us to place our ores, and we will be making the first 2 public. The way to do this is with an access transformer. Now that sounds quite complicated, and generally speaking, it looks a little bit crazy, but do not worry, let's take a look. Inside of our resources folder, we're going to right click and make a new directory called meta-inf. Extremely important that this is written exactly like this. It has to be all uppercase and it has to be meta dash or like a minus inf, all like that. And then inside of it, we'll make a new file called the AccessTransformer.cfg. I want you to double check the spelling on this like 2 or 3 times. It has to be written exactly like this. If you're unsure about the spelling, either of course you can check the GitHub repository, or you can go to the build.gradle file and you can see right here it's also written. You don't have to necessarily uncomment this, but you can see this is where it has to be. Source main resources meta-inf AccessTransformers CFG. It has to be written like this, otherwise it's not going to work. Very, very important. And here we can basically target different methods, fields, or anything inside of the vanilla classes, and we can make them public. That is really useful, but it can sometimes look a little bit crazy. So the way that it's going to work is we of course want to make this public. So we write public. That's all fine. Then we have to decide what is the class that we want to target. Now, the way to do that is we want to take the package of the target. So this one right here, and I'm going to copy this over, right? I selected it and pressed Control C to copy it over and paste it in. So this is the package sort of structure. And then dot the name of the class, which is or placements. Then a space, and then the particular, in this case, the method that we want to make public, which is or placement. Here, now it gets a little bit weird. It's going to look kind of crazy. Because what we now need to do is we now need to basically take in what the parameters are and do the same thing with the, net Minecraft, whatever. So I have this written out already. So this is L meaning this is an object. So if you had an integer, which we're going to see in a second, it would not be L, it would be I, for example, or B. But I also, we will link a really good wiki article from NeoForge themselves down in the description below. Highly recommended to check that out. And this is under lnet/Minecraft/world/level/level_gen/placement modifier. Yes. And then a semicolon L, because we have a second parameter, net/Minecraft/world/level/level_gen/placement modifier, making sure we write this correctly as well. Modifier, then we end with a semicolon, and after the closing parenthesis, we'll also have L Java/util/list, and then end it with this with a semicolon as well. So you can see this is a very, very long thing over here. I highly recommend you do go into the description in the GitHub repository and you copy this over, because it does make a lot of sense, because having to type this out, it's very easy to make a mistake. And we will copy over the last two that we also need. You can see this, the common ore and the rare ore placement, and the same thing goes here. It's just an I, and notice that even though the the first one is an integer, this is why it's an I. If it was a boolean, then we would have a B, for example, and so on and so forth. And then the L immediately comes after. There's no semicolon. The semicolon only comes after the sort of class names in this case. So now we have this. We now open the Gradle tab and we run and sync all Gradle projects. This now once again takes maybe, a minute or so. Probably not. It's most likely going to take a couple of seconds, but we just let this run through. And once this has done its magic, then, there we go, 37 seconds. And with the magic, if we now go to the OR placements, look at this. Boom, boom, boom. All three of our methods that we need are public now. Isn't that really cool? AccessTransformers can be extremely useful, so I do highly recommend you read the article on this, as they can open up quite a few things. But now we can proceed to add the configured features. The configured features are set up in the following way. We're basically going to have a bunch of resource keys, and for all of this, we need some helper methods. The helper methods start kind of like this. We're gonna have a private static, and this is going to look insane. Once again, for your own sanity, I highly recommend you go to the description to the GitHub repository, because this is going to look crazy. So this is for the mod configured features, and this is the register method. Private static. Then we have the angle bracket, or smaller than FC, which extends from the feature configuration. This is the feature configuration interface, correct? Then comma. Then the F is going to extend from the feature class, this one exactly, which is of type FC. So you can see we start off very crazily. The return type of the register method is a void, and then this is the register method. The parameters of the register method are a bootstrap context of type configured feature. This is of configured feature of type question mark, comma question mark. We're going to call this here the context. The second parameter of the register method is a resource key. This is the resource key of type configured feature. Configured feature, exactly, of type question mark, question mark. And this is going to be the key. Then we have an F feature, and then we have an FC configuration. There we go. And this is the entire method. Looks absolutely insane, but that is what we're going to need. we're going to have the context called the register method. So context.register, passing in the key, then making a new configured feature over here, configured feature. And this is not necessary to do this. We can just leave the angle brackets empty, and then we just pass in the feature and the configuration, and that is going to be fine. That is the first helper method. Luckily, the second one isn't as crazy. The second one is just going to be a private static resource key of type configured feature. And that's not quite right. This is a resource key of type configured feature of type question mark, comma, question mark. And this is going to be the register key method with a string name parameter over here, where we simply return resource key. That is resource key.create. You can see it suggests this to us already. We just selected, press the tab key to auto-complete it. And then we have registries.configured feature. The second parameter here is an identifier from namespace and path. So we just also use that one. And then we have the academy mod.modID, passing in the name over here. And there we go. That's going to create ourselves the resource keys. And we will see this pattern, basically the same pattern is going to repeat in the placed features and the Biome modifiers, because it's a very similar way to set this up. So we're going to have a public static final resource key of type configured feature over here. So this is the configured feature of type, once again, question mark, question mark. So basically every time we have a configured feature, it usually is of type question mark, question mark. And this is going to be the overworld underscore oric underscore or key over here equal to the register key method, where we are going to call this here the oric underscore or. You can also call it oric underscore ors or whatever you really want here. The important part is that you're not restricted to only have one. In theory, we could also have, oric or small, oric or big. You can, of course, do multiple with the same ors in theory. We're just going to have one in this case, though. I highly recommend, if you're interested in this, to check out the OR placements. No, that's not quite right. It's actually going to be the OR features class that you wanted to check out. That one has all the different OR features from vanilla, for example, OR diamond small, OR diamond medium, OR diamond large. That's what I mean, right? You can have multiple of those, of course. Highly, highly recommended to check those out. Next up is another resource key over here, which is going to be the resource key, of course, configured feature, colon, question mark, question, colon. It's actually angle bracket, but that's okay. And that is going to be the nether underscore oric underscore or underscore key. And we could call it nether or, but I think we're actually going to call it the nether underscore oric underscore or. I think that's fine. And for the third one, we're just going to duplicate the line and change the nether to end, and always, or never forget to also change it inside of the name right here to end oric or. Those are going to be our three resource keys for our configured features, and we can then make a public static void bootstrap method. Now, this bootstrap method is extremely important. It will take in a bootstrap context of type configured feature. So this is of configured feature question mark, comma, question mark. I'm going to call this here the context. And the way that this works is whenever you see a bootstrap context within the context of Minecraft modding, that means that we are making JSON files sort of with code. And this is what we're sort of defining. We're defining the JSON files inside of this bootstrap method. It's very interesting the way that it works, but that is what we're going to see basically the two other times in the place features and the Biome modifiers as well. Now, for our ors to be properly placed inside of the world, we need to define rule tests. Now, this at first is going to seem a little bit weird, but then you're going to be like, oh, this makes total sense. So the idea is as follows. We're going to have a rule test over here. And this rule test is, for example, the stone replaceables. So stone replaceables. And the idea here is as follows. The stone replaceables are going to be a certain match. So we're going to say, hey, so the idea being, we're going to go through the entirety of the world. Just imagine this. We're going to go through the world. We're going to be like, okay, I want to place this oric ore down. But where should I place it? Where can I place it? Well, only in certain rule tests where something matches. So this is going to be a new tag match test where we're going to say if the block tags dot stone or replaceables, right? If we find that, which in this case would be, for example, this should be tough, diorite, stone, those are the stone ore replaceables, meaning that we can place the stone ore inside of those stones If we find that, there we go, we got it. Those are replaceable. And if we find deep slate, well, that doesn't work because that's not a stone ore replaceable. Instead, it is a deep slate replaceable over here with the, exactly, deep slate ore replaceables. So this has another tag over here. Absolutely fantastic. Now, that is for our overworld ores. Easy enough. Now, we also need one for the netherrack replaceables. And this one, instead of being a tag match, this one is actually a block match. Because in this case, we only want to do blocks.netherrack, and we only want to replace netherrack. So here, we're basically directly defining, okay, what can our ore replace in the world? Because the world already exists, right? The stone and all of that is already placed down, and we're just saying, hey, what can we replace over here with this? And that is very important. And the final one here is, of course, the end replaceables. And it does, actually it's correct, yes. So this would be the block match test of the end stone, because there's actually nothing, I don't think that there's another block in the end anyway, so obviously it makes a lot of sense to just use the end stone. I think in the nether there's another like tag for the nether stuff as well, but in this case I do think this makes sense, because like the nether ore is going to look like nether rack anyway, so I think that that does make a lot of sense. Next step is to call the register method, and this is going to be the first one for our overworld ores. So we're going to pass in the context from the parameter, then we're going to pass in the overworld auric ore key, then we have to do feature.ore, because this is an ore feature, then we're going to do a new ore configuration, and then here this is going to look a little bit crazy, but for our overworld ores, our rule tests are going to be two, the stone replaceables and the deep slate replaceables. So it's going to look slightly different to how it looks for the other ones, because this one is going to be a list.of, and then passing in as the first parameter the stone replaceables. And this is a list of ore configuration. So inside we say ore configuration that target, passing in the stone replaceables, and then modblocks.auric ore. So this is now where we define the block that we actually want to place down. Auric ore.get.default block state. There we go. And then we have a second ore configuration.target, because we also want to place down the deep slate replaceable, or rather we want to replace the deep slate replaceables with what block? That is the second one we define, which is modblocks.auric deep slate ore, once again, .get.default block state. And then here after the list, right, so this is going to be the first parameter of the ore configuration, and the second one is an integer. This is the size of the ore vein, that's the whole idea, and that is the overworld one's done. Now, this one is the only one that's slightly more complicated because we have two different replaceables over here. You can think, for example, in the nether, if we had a nether rack, like a nether ore, as well as like a basalt ore, then we would have the same sort of list in the nether one. But in our case, because the nether is only one, we once again call the register method, context, then passing in the nether auric ore key feature.ore. Then once again, this is the same thing, new ore configuration, but this time we just pass in the netherrack replaceables, then what is going to be the block that we place down, modblocks.auric netherore.get.default block state, and once again, a size of the veins over here in this case. And the final one, we can duplicate the register method. Here, of course, very, very important that we are very cognizant of all we do, the end auric ore. Then we have the end replaceables, and then we call the auric end ore over here, and there we have it. That's going to be the 3 register method calls to create our configured features. Now, what you'll find is that the bootstrap method is not yet called. That is correct. We're going to do that at the very end, because for it, we will need to make a new method over here, or a completely new class actually for our data gen in order to create these JSON files, because those are data pack JSON files. Because we've gone through the idea of the helper method and the register key method first time around in both the place and the place features and the Biome modifiers, I'm going to be a little bit quicker and going to copy a couple of things over here, but you'll find it is basically the same idea. And as always, you always have the code available to you down below. I highly recommend that you have the GitHub repository open in the background anyway. It's always a very good idea. So here you can see that the helper method is going to be a bootstrap context of place feature this time, with a resource key of placed feature. And then here we have a holder of a configured feature. I'll explain that in a second when we actually register our place features. And then finally, we have a list of placement modifiers over here. And then here, when the resource key of place feature, it's the exact same thing that we've seen with the configured feature, just that now it is a place feature. That's literally the only difference. And then we can do the same thing for our 3 ores over here. So there's going to be a public static final resource key of type placed feature this time. Luckily, the placed feature isn't a generic, so we can just placed feature. That's pretty nice. And that's going to be the auric underscore ore underscore placed underscore key. That's how I call it. And then when I register the key, I always do auric or placed. That's correct. I always like to add the placed over here at the end of the name. Just feels right in my opinion. All right, we'll duplicate this twice over here for both the nether underscore auric as well as the end underscore auric or placed. Never forget to change the names over here as well. It's a very easy mistake to make. The game will yell at you when you try to run it, so it's not too bad, but still, it does make a lot of sense. So then we get to the bootstrap method once again, because like I said, the bootstrap method is always going to be a way to, well, basically create new JSON files for specifically when it comes to data packs, right? So there's a data pack JSON files. That's going to be the context right here. And then let's see. This one is going to be slightly different, or it's going to have a different start. And that's going to be a var called configured features. Configured features. There we go. And that's going to be equal to context.lookup, passing in registries.configured feature over here. Now, the reason why we have this is to reference the configured features. We'll add the first one, and then we'll go through each of the different things and what they mean. So we call the register method, passing in the context, then the key that we want, in this case, the ore placed key for our overworld ores. Then we pass in the configured features var over here, which is a holder getter. Sounds a little bit complicated, but I'll explain in a second. And then this is where we're going to get or throw. Let's get or throw, passing in mod configured features dot overworld auric or key. After the first closing parenthesis, we'll then continue with the ore placements dot common ore placement, let's say for example 12, and then we're going to use the height range placement dot triangle, and then let's say here we're going to do a vertical anchor of absolute with -64, and the second parameter in the triangle method is another vertical anchor with absolute. Let's go with 80 over here. And I'll reformat this slightly differently, and then we can see, let's actually reformat it like this. There we go. So we have like each of the different things that we can do sort of in one line, so we can explain this. So starting with the configured features, what is happening here? The idea is that we are, of course, like I said in the very beginning, we are now placing down a specific configured feature, right? So we've configured the feature to say, hey, we can replace stone with the auric ore, and that's going to be of a size 8, right? And this is how our feature looks like. So we've configured it. That is our configured feature. Now I want to place it down in the world, and I of course need to know, okay, how many are we going to place down? That is the 12 right here via the common ore placement. And then we need to have a height range, right? So from where to where are we going to place this down? In this case, it's going to be placed down from -64 to 80. That is the idea. Now this is in a triangle formation. You've probably seen the image of the quote-unquote new ore distribution. It's a little bit older at this point, but this triangle is, well, a triangle where at the top and the bottom of the distribution, so -64 and 80, right? So it's going to go from 64 to 80. That's going to be the fewest ores, and then in the middle where they meet, which should be 16 if I recall correctly. Yeah, I think that should be Y level 16. That is where you're going to find the most ores of this particular type. And that's how this is basically set up. There's also the uniform distribution right here, where it's going to have the same likelihood in each Y level to appear. That's the idea, and that's what we're going to have. Now, we're just going to use the triangle. I think that's fine, and that's going to be okay. We can duplicate this 2 times over to also get the nether auric ores over here. And of course, then we need to pass in the nether auric ore configured feature right here. And the same thing goes for the end ore right here and the end auric ore key right here. In theory, the numbers can stay the same. You can, of course, always adjust the numbers. This is a place where I highly recommend you test things out. What I also recommend you do if you, let's say, go for the rare placement over here, right? So the rare placement over here, or basically just a different placement or a lower count, that's all fine and well. You can absolutely do this. I always recommend you test with a slightly higher count at first to just see if everything works, because lower counts obviously are, well, rarer, so you're gonna have trouble finding them. So I do highly recommend you make sure that that is the case. With the place feature done, we can now move on to the biome modifiers, where we're only gonna have one helper method, luckily, so that's nothing too crazy. There's once again a resource key, this time NeoForge registries.keys biome modifiers, because like I said, the biome modifiers are the NeoForge way to basically, well, add the ores, the place features of your ores to the world. And here, I'm also going to copy over the 3 resource keys because we've seen this twice now, one after another, and you can see the same idea goes. I just like to, add the add word over here to note, hey, this is what we're going to add to world gen. Because in theory, you could also remove with the biome modifiers, but we're not going to do that in this case. We're going to have another public static void bootstrap method with a bootstrap context of type biome modifier over here. I'm going to call this the context. And then let's take a look. For this, we're not only going to need a holder getter of place features, because we once again need to refer back to the place features, because that's the thing that we wanted to set down in the world, but also we will need a biomes holder getter, because we want to say, hey, this should be placed in this biome. So we're going to have a var placed features equal to context.lookup registries.placed feature, then a var biomes equal to context.lookup registries.biome. That is exactly right. And there we go. Let's add the first one, which is context.register, passing in the add auric ore. Then we will make a new biome modifiers.addFeatures biome modifier. So this is going to add this, right? I mean, as the name suggests. The first parameter is going to be biomes.getOrThrow. And here we're going to choose a biome tag. So we're going to say biome tags.is_overworld, meaning that we're going to basically add the auric ore and the auric deep slate ore in all overworld biomes. I think that's fair. I will also add an example in just a second to specify individual biomes just after we've done this. Then we have a holder set.direct right here. This holder set.direct will have the placed feature.getOrThrow, and then mod place features.auric or placed key. So here we are referring back once again to our place feature, which we wanted to set down in the world. And then because this is an ore, we wanted to use the generation step of underground ores. Very important that your generation steps are basically always the ones that you want to use. So for example, for a tree, you would use vegetal decoration. If you added a lake, you would use lake. In our case, we are doing underground ores, so it is underground ores. Very, very important. Now, I will also add as a comment here the example for individual biomes. You can see then you would also make a holder set of direct, and then you can add as many biome get or throws right here as you want, and you just use biomes dot and then whatever the name of the biome is in this case. We're not going to do that. We're just going to use the biome tag in this case, and what I'm actually going to do is also take this and copy it over twice to change for the nether as well as the end, because that's going to be very, very similar. So we're going to have the add nether auric right here, where what is this going to be? Well, is nether. Easy enough. And of course, don't forget to change the mod placed feature over here to the nether auric or placed key. Very important. So we want to place the nether ores in the nether and with the nether key. Yes, exactly. There we go. And then with the end key, well, this is going to be the end auric or key. There we go. We're going to place those in the is end. And here, of course, we're going to place down the end auric or placed feature inside of the end over here in this case. And that is going to be the biome modifiers as well. They can be super versatile, very, very, very cool in this case. And that is going to be the last big class that we need. Now we're going to make the data pack built-in entry provider. Sounds crazy, but it basically just enables us to call these bootstrap methods for specific registries. Let's take a look. So this is going to be in our data gen package. We're going to make a new Java class called the ModDatapackProvider. That's at least how I call it. And this is going to extend from the data pack built-in entries provider. There we go. Like I said, looks crazy, but generally speaking, we're going to just hover over this to create constructor matching super, where it doesn't matter. We're just going to use the first one. Because we have to change it anyway, we can remove the set over here. And these registries are actually going to be a completable feature of a type holder lookup dot provider over here in this case. And then in the mod IDs, it's as easy as doing set.of and then passing in our mod ID, which is academymod.mod ID in this case. There we go. Now we're going to be missing one parameter in this super call, and that is going to be a builder. This builder, we're going to add ourselves over here. This is going to be a public static final registry set builder. So this is a registry set builder. I'm going to call this builder all in uppercase, which is a new registry set builder. And then we're going to have an add call. And each one of these add calls, that is where we define the registry and then the bootstrap method. So there's going to be registries.configured features, not the configured carver. Very easy mistake to make. It's a configured feature and then comma mod configured features colon bootstrap. And then we call this add method 2 additional times. Once for the placed features, where we call the mod placed features colon bootstrap. And then here for the, this is important, for the NeoForge registries.keys.biome modifiers, and then this is going to be the mod biome modifiers colon bootstrap. Finally, we pass in the builder right here, and that's going to fix the error right there. Absolutely fantastic. We can then move to the data generators class, where we're going to call generator. This is generator.addPack with a true over here and a new ModDatapackProvider. And this is exactly right, passing in the pack output as well as the lookup provider. And there we go. Long was the journey, but there we have it. So now we have all 3 of our bootstrap methods code. We can see this by, them turning yellow right here. And that is absolutely fantastic. And we have everything set up in the way that we need to. So we can now go to our data over here. So we're going to run the data gen. Alternatively, you can also use the data gen right here in the Gradle tasks. And then under the mod development, run data. That also works. And you can see this now generated 34 JSON files. Now that is quite a few. And of course, those are all in the generated right here. Generated data, academy mod. And here in the world gen, we have not only our configured features, which you can see this is exactly what we set up. Stone or replaceables, tag match. Then we have the state over here that we place down. So this is our block that we place down instead of stone ores. Absolutely fantastic. The place features are here under Academy Mode NeoForge. This is where our Biome modifiers are at, and that is exactly what we have. So absolutely fantastic. Basically, yes, you can say we went through all the trouble with these 3 classes for these 9 JSON files, right? For these 3, and these 3. But of course, the point is that if you now have, you now want your auric ores to spawn in 3 different veins. Well, boom, you go in, you make, 3 other configured features over here. Maybe you're like, I actually have like 12 different ores that I want to add. Well, I mean, good luck. And yes, of course, these JSON files, because they are basically data pack files, you could add them manually, but this is the way of madness, right? Especially if you want any sort of custom placement or anything like that, specifically when the place features come in. Yes, this is like still fairly simple, but the place features can also get quite complicated. So I do recommend you always use DataGen for this. It just makes sure that everything works fine. But with that being said, let's jump into the game and see if it works. I do recommend to create a new world right here. It does make a lot of sense in my opinion. And let's just take a look and see. All right, we're back in Minecraft and let's just go and descend downwards and let's take a look. So because Y level 16 is the highest likelihood of them showing up, I usually find most of them, there we go, in the layers of deep slate. But there we have it. We got ourselves some auric ore, and that's not everything, of course. We can, of course, also check out the Nether, where in our case, it might be a little bit harder to find it because it looks similar to the gold ore. But of course, there we already have it, like literally like the first thing to appear. And I mean, I guess the end is going to be the end. And this is usually the easiest one to find because you can see, boom, there it is. Because there's nothing else over here inside of the, inside of the end because, well, there's no other ore. So it's very easy to find. And there we go. That is going to be custom ores over here added to Minecraft with custom world gen. So awesome. Thank you so much for watching. I really hope you enjoyed the video, and don't forget to subscribe to the CurseForge Academy channel for more modding tutorials just like this one. See you in the next video.